Oh, we're at 11 o'clock here, are we? Time to go.
Hello, good morning, good afternoon, and good evening, everybody, wherever you are. This is the episode number 259, DB2 Warehouse Gen 3. Hope you're following us on Twitter, our YouTube channel, and DB2Night show. Our goal is to educate DB2 community on the existing and the new features available within DB2 on-prem and cloud. Today, our special guest is Les King, IBM data architect from Toronto Lab, and he's going to be taking us through the DB2 Warehouse SaaS Gen 3. Hi, Les.
Hey, good morning and welcome. Thanks for inviting me to join you.
Well, thanks, Les. Thank you. And your guest today, your host today, my name is Mohan and Martin, Gold Consultants and IBM Champions. Let's go through a little bit on the night show. So please do follow us on Twitter or X, and replays are going to be available on YouTube as well as the night show replay blog. And feel free to join us on LinkedIn. We have about 1,300 or 600 members connected over LinkedIn. Please free to join us there. Disclaimer, I'll let you read for about a second. Right, night show announcements. We have an upcoming session next month, August 23rd. Raghu from IBM Software Labs Bangalore is going to present DB2 FAQs, the performance FAQs, the cookie cutter SQL statements, and what you can do for a specific performance issue. And all of the webinars are going to be available within our DBI software website and also the YouTube. Thanks for our sponsors. DBI Night Show is sponsored by DBI and Martin Hubel Consulting. That's going to go away and then it's going to be replaced by DB Automation. Right, so we have a few questions. Move your mouse. We have certain few polling questions for you to answer. Let's start with the very first one. Right, let me know when I say it. Please feel to answer the questions here. We got 20% voting, 40%. Let's give about 2 more seconds. I'm going to manage the poll, close the poll, and
Then yep. Oh, there you go.
I'm not able to showcase the result.
Maybe you closed a little too quick because we didn't get anybody to vote.
Oh, we had votes. Okay, I'm going to share it. Yeah.
All right, there it is. There it is.
Right.
Yep, we're seeing them now.
All right.
People are moving up.
It's great to see how many people are on the latest and greatest.
Oh, yeah, 80% of them are higher on the greatest. Let's go with the second poll question. All right, I'm launching the second. Are you using DB2 Warehouse on cloud? Yes, no, or planning to use? Okay, 100% says planning to use. Share the result.
All right, well, that's good because we'll definitely be talking about DB2 Warehouse SaaS today.
Exactly. Yeah, right. All right, the next question is about RDS. So we have DB2 in RDS and AWS. How many people are using it or planning to use it? I think about 60% of the people wanted to migrate the database to RDS. That's pretty good. All right, closing the poll, sharing the result. So 67% planning to migrate to RDS and 33% no. The question is about, is your organization cloud-centric? Are you using a lot of cloud features or cloud products? All right, collecting the responses. We're going to close the poll. Okay, so we have about 75% plan in use and yes, about 25%. If you're cloud-centric, who is your cloud provider? AWS, Azure, IBM, GCP, or others? Collecting the responses. All right, 5 more seconds to go. Closing the poll. Share the result. AWS taking 60% of the marketplace, or 20% IBM, 20% GCP. Interesting. No Azures. All right, the last question. Oh, that's about it for today. And then we have a last question at the end. All right, this is about the episode 259, DB2 Warehouse Gen 3. We'll hand over the mic and screen to Les.
All right. Let's see here. Show my screen. Let's go to.
I will watch the chat for any questions. I'll let you know.
All right. Can you see my title page right now? Is it looking good?
See it.
All right. And you can hear me okay, obviously?
Yes.
All right. Thank you very much for the intro, man. Really appreciate it. And thanks so much for inviting me to join here today. And as mentioned in the polling questions, we're going to be talking a little bit about DB2 warehousing, and in particular, DB2 Warehouse SaaS Gen 3, but also want to paint a little bit of a broader picture of our investments in the warehouse space, just so everybody gets a complete picture for those of you who are still on premise or maybe using an appliance form factor with DB2 warehousing, so everybody has a complete picture. But obviously, cloud is where we're seeing a lot of interest and a lot of popularity of clients interested in moving to, and then also how we plug into our Watsonx.data architecture, which is really all about Lakehouse and the evolution of a data lake and the data warehouses into a Lakehouse. So we'll kind of paint this whole picture, and obviously DB2 Warehouse SaaS Gen 3 is going to be kind of front and center of what we talked about today as well. So yeah, please post questions. I assume there's the chat room for posting questions, and Martin and Mohan can feel free to interrupt me at any time if there's any questions that you think
Sure.
you'd like me to pause and answer. So
Sure.
Let's just start with a couple of strategic drivers, right? I always want to remind people that whenever we talk about DB2 functionality, that functionality is in our code base regardless of the deployment form. We've called this the common engine, the common SQL engine. But really the key is that we have one code base, whether you're running an appliance, whether you're running on the cloud, whether you're running on premise. And so everything we talk about when we get into functionality is available in, it's the same code base regardless of your deployment form. Secondly, we always try and keep in mind all of the evolving needs of the various data disciplines. So that includes the engineers, the DBAs, of course, developers and architects, but also those who are consuming what's inside the warehouse and what's inside DB2, the business analysts and data scientists. And we're always trying to strike a balance between continuing to invest in our foundational capabilities around security, availability, resilience, scalability, performance, and so on, as well as positioning DB2 to handle the evolving workloads of the future that get into multi-model type support and get into NoSQL type applications and containerization from a deployment form. So there's a lot going on from the point of view of how database deployments and workloads are modernizing, and we want to address those needs while making sure we're continually investing in the solid foundational items that everybody knows and loves about DB2. And of course, AI, right? Can't talk about anything these days without talking about AI, and AI is front and center from the point of view of DB2, both in leveraging AI technologies to make DB2 a smarter database engine, as well as being able to leverage DB2 as a place to store your data in that collect phase and the organized phase, so that information architecture phase of any journey to infusing AI into your applications. And as I mentioned, from a modern deployments perspective, this is front and center in our investment areas. And as we talk about warehousing, you're going to hear me talk about several of these items in the world of warehousing, and how our warehouse, whether it's in the cloud or on premise or appliance or whatever, is ready for the evolving workloads in the warehouse space, which again get into multi-model, mixed workloads, right? Operational analytics, deep bulk scan analytics, ODS workloads, reporting workloads, and also the doorway to all of your business data. So even if there's data that's not stored inside DB2, that you can use DB2 as a consumer and get through that data virtualization doorway to all of your business data, regardless of where it sits. So I just wanted to kind of lay that, so a few foundational concepts right at the beginning. So as we kind of get deeper into what we've been up to in the world of DB2, that we're kind of keeping those influencing sort of dimensions on our plan and where we invest our engineering dollars in mind. So the other thing that's worth mentioning right now is we're kind of at a pivotal point. You're going to hear me mentioning 11.5.9 quite a bit. 11.5.9 was actually first delivered in DB2 Warehouse SaaS Gen 3. So we did do a cloud first delivery of 11.5.9. But we're also at a little bit of a pivotal point right now where 11.5.9 is the last mod pack that we're going to have on the 11.5 code base. 11.5 came out back in 2019, and here we are 4 years later. And there will be no new function on the 11.5 code base. And I'm actually going to wrap up today's presentation with a couple of words about what's coming next. And so we do have a version 12 that we're working on right now, and there's going to be more about that later in the presentation. But we will, of course, continue to have our special builds and fix packs and basically fixes being delivered on the 11.5 code base, but new function now is going to be on our kind of vNext. So what did we do in 2023 and into the beginning of 2024 as it pertains to warehousing? So the first thing we did is we delivered our first cloud rack. It's power-based, and that is the appliance form factor of DB2. It's kind of the next gen to IIS, right? So if we kind of do a little back in history, we had the pure data system for operational analytics, which was DB2-based. And then we had the IBM integrated analytics system, where we attempted to take on some of the workloads that Netezza, that was branded Pure Data System for Analytics, PDA, kind of converged on some of the warehousing workloads there in IIS. And then now we have our next gen, which is the Cloud Rack, and the power-based version of that is out there now. DB2 Warehouse Gen 3 came out in third quarter, and like I said, that was a cloud-first delivery with the DB2 11.5.9 code base. And we'll go through some of the highlights associated with what Warehouse Gen 3 really focused on. It came out on AWS first, and that was back in third quarter. And then we have basically a design and an architecture ready to go for the Warehouse Cloud Rack on x86. So that hasn't actually GA'd yet. We do have some clients trying it out, but it hasn't gone full GA. There's a couple of things we still want to further optimize when it comes to performance and scalability with the x86 version. So right now, from a GA perspective, only the Power 10 Cloud Rack's available. And then we had our full 11.5.9 software release. So all the great functionality we put into 11.5.9 that went out in DB2 Warehouse Gen 3 is available for all clients now, regardless of deployment form, including on-premise, with the full software release that went out right near the end of last year. So that was basically our calendar. And that's on the same calendar, IBM's response to the world of AI and Gen AI, and what are we doing to help clients in their journey to infusing AI into applications, and then to evolving workflows with AI to eventually get to the point where AI is doing a lot of the work. We introduced what was called the IBM Watsonx brand. And the Watsonx brand has basically 3 cornerstones and a whole ecosystem sitting around it. We're not going to spend a lot of time on that. But .ai is where all of the AI work takes place. This is where you're working on your models and you're doing your inference and error detection and building out and refining the models. And so all of the true validation, training, tuning, deployment of any of the AI work you're doing, that's going to leverage Watsonx.ai. And then we have Watsonx.data, which we're going to drill down a little bit more. That's the whole world where DB2 plays. And Watsonx.data is the platform for the Lakehouse, right? That evolution, and I'll say a few more words about this, that evolution of the data warehouse and the data lake into a Lakehouse architecture, that's what Watsonx.data is, and that's where DB2 plays. So we'll be drilling down on that a little bit more. But before that, the third kind of pillar or foundational sort of the third leg of the stool is Watsonx.governance. And this is where you deal with adhering to all the regulatory demands that are out there right now, taking care of ethics and brand image and protecting yourself and being able to have transparency. We all know in the world of Gen AI, we can all just look at what's happened with ChatGPT and what's happened with Alexa and things like that, that every once in a while we don't get the anticipated results, right? There's some unintended consequences around bias and hallucinations that have come out in the world of AI. And governance is how you deal with all of that, how you make sure that you're providing transparency, you're following good ethics, that you've got the regulatory alignment that's required in the world of AI. So let's drill down onto Watsonx.data, because that's what that's where the whole world of DB2 warehousing plays. So a few things have gone on here in the world of the warehouse space, right? So the first thing is, we had our bottom left corner, we had our traditional warehouses and analytic applications. And the first thing that happened is people started looking for less expensive. We all know that traditional warehouses, block storage, so on, that's not cheap, especially as they start getting very large. So there was a push towards data lakes. And data lakes was basically an open source platform, Apache projects. You had the Hadoop platform with its own HDFS file system. You had a whole bunch of Apache projects like Ranger for security and Hive for a Metastore, and so you basically had open source, and it was all based off of a commodity hardware platform. So that, hey, you have more data and more data you want to put into your landing zone, you scale out, and you're picking up commodity x86 hardware, which is not expensive. And then it tied into things like Cloud Object Store as a less expensive storage tier, and out came data lakes. Now, a lot of the data lakes did not work as designed. Having a landing zone is all good, but you still need to do cleansing, right? It's no good to a data scientist or business analyst if there's no way to integrate the varying disparate sources of data that are now inside the landing zone. And unfortunately, what happened is a lot of the data lakes became coined as a data swamp, because it was a landing zone of a bunch of data which consumers really didn't know how to pull all of that data together cohesively. And so now we're realizing, okay, well, data lakes aren't going to replace data warehouses. There's still lots of workloads that companies have with SLAs, and there's a willingness and a need to spend the money on certain warehouse workloads. and that is continuing to be there. But then there's also the less expensive way of dealing with analytics with the data lake. So both will exist. And this is where we're seeing the kind of merge into the data lake house world, right? It's going to take the best of both worlds and bring it together and absolutely have your block storage, more expensive storage tiers, high performance components to the lake house, and then have the less expensive leverage native cloud object stores and the ability to have a separation of compute and storage, which is something that traditional data lakes lacked in the Hadoop space that, of course, we want to have, right? We don't want to have to invest in more storage if what we want is more compute capacity and vice versa. And in comes the lakehouse. And we'll get that in more detail. And then it's really happened on the same calendar, but an independent trend, and that is the shift to the cloud. Whether clients were moving their warehouse to the cloud or their data lakes to the cloud or now their data lakehouse to the cloud, the whole shift to the cloud is taking place while this evolution from the traditional warehouse and independent data lakes are shifting to the lakehouse. So from a data lakehouse perspective, this is about implementing different data structures or different models of data, including traditional relational data, and having all of the sort of key management features with low cost, flexibility, reliability, scalability, and being able to have a feature reach capability for all of the data in the lakehouse. Now, where did the term lakehouse came from? Very obviously, it's the combination of a warehouse and a data lake, right? As I mentioned already, the best of both worlds. So what's IBM's stance in the world of a data lakehouse? IBM's position on this is, we want to protect companies' existing investments. So if you've already invested in the DB2 family from a warehouse perspective, we want to protect that investment. If you've already been working with DB2 Big SQL and have deployed a Hadoop environment, we want to protect that investment as well. And so what you can see here is that the components that are coming together in the IBM data lakehouse, and that's really what Watsonx.data is. It is our architecture for the lakehouse. We're giving you access to traditional query engines as well as open source query engines. We're leveraging the metadata that you may already have out in Hive, right? We're leveraging object store for the ability to leverage data that's already out there, integrates with DB2, which we're talking about today, but also Netezza for ensuring you've got the right engine for the right workloads. And so where you already have your high performing block storage tiers for the SLAs that you have, then you continue to use that. And that is absolutely an integrated part of the data lakehouse. And it basically takes with investment protection, takes the best of both worlds. And I really like this picture as sort of the way that pulls it all together. And so let's just kind of walk through this. There's a bunch of different points here, but we'll just basically highlight a few things. So you can see DB2 warehouse there on the top left, right? And that now DB2 gives you the ability to store your data either in block storage or in object store. So you can take a native DB2 table and store it in object store, and you get the cost savings associated with object store, but you still have full IUD capabilities, and it is a true native DB2 table. We're going to drill down on that a little bit more. The same story with Netezza as being part of the world of data lakehouse as well. The second thing you'll see here is the ability to have open data format type support with Parquet, Avro, ORC, JSON, CSV, delimited. So from a DB2 lens, think of this as an expansion or extension of our external table support, bringing in the code we had in DB2 Big SQL, because it's all part of the DB2 engine, to open up what traditionally was our external table support for CSVs and sort of delimited and sequence type table formats, now bringing the rest of the Parquet, Avro, ORC into play, and then leveraging Apache Iceberg as a front end to all of that, so that some of the restrictions that are there with these open data table formats can be removed, and it allows us to leverage SQL engines such as Spark and Presto. So you don't have to just have the native DB2 SQL engine. You can leverage Spark SQL. You can leverage Presto. As you can see here, it plugs into a Hadoop environment. Hive, for instance, is the metastore. You can leverage Ranger for your security policy. So the investment that you have made in both Hadoop and in DB2 all come to the table in the world of IBM's position on a lakehouse. And I think we've basically talked about all of these different components. So I'll just flip through this quickly here. And in comes now a couple of new features that we have added to the DB2 engine to help make DB2, the DB2 warehouse, a nice, seamless, integrated player in the world of Watsonx.data, or in the world of the lakehouse. The first is what's called a data lake table. And a data lake table is, as I mentioned, really an extension of our external tables. So if you're coming at it from a DB2 engine perspective, it's external tables. If you've used DB2 Big SQL, it's taking that DB2 Big SQL code and bringing it into the DB2 warehouse portion of the engine, because it's all one code base, as I mentioned before. And this is what's given us the support for Sequence, Delimited, which was there before, Orc, Avro, Parquet, and all leveraging and serializing on an open data file format. All right. There's a metastore that we leverage, which is Hive, same metastore that you may already have in place as part of your Hadoop environment. And this gives you the ability to have very shareable information across many different applications. So it's a huge part of the integration story. And if we take a look at the underlying architecture, you would, if you're a Hadoop person, you're going to recognize this as, this is what Hadoop looked like, right? And what was DB2 Big SQL? DB2 Big SQL was DB2 DPF supporting HDFS. And so the green boxes that you see there, that's just DB2 DPF, right? You've got your coordinator node or head node, and you've got a whole bunch of worker nodes. Those are just the partitions in a DPF environment. And of course, we have the Hive Metastore, Ranger, Zookeeper, the Apache projects all plug into this just like they did with DB2 Big SQL. And we have the Iceberg engine there to deal with the open data format, and we'll define Iceberg in just a moment. But really what we're saying here in the warehouse space is that this whole data lake table support partitions out and gives you the scalability of a DPF environment and leverages the same architecture that DB2 DPF, our MPP topology, brings to the table. And if you're coming from a DB2 Big SQL background, it is exactly that, right? It is DB2 Big SQL for the data lake tables, okay? Now, there are some limitations. We know this. If you're an external table user, you'd know this. If you're a DB2 Big SQL client, you would know this as well. There's like no ACID properties. You don't have kind of your concurrency with the 4 isolation levels. There's no notion of state or history type of thing. There is a need for a catalog, right? We have to know where data is and what the data is there, and that's where the Hive Metastore comes in. And those are the same restrictions we've had with external tables and we've had in DB2 Big SQL for a while. But in comes Iceberg, which is basically an open data table format that sits on top of those storage types like Parquet, Avro, and so on. And really what this has brought to the table is the ability for us to open up these tables to other SQL engines like Presto and Spark SQL, but also it's given us the ability to start chewing away, having a common interface above all these different storage formats has given us a way to start chewing away at some of those restrictions. So for instance, external tables and DB2 Big SQL traditionally didn't support granular update deletes, right? It was an ingest query type platform. That's what HDFS was focused on. And you didn't have that granular update delete unless you were using a native DB2 table. Schema evolution was difficult, as of queries for time travel type historical analysis wasn't there. And by the way, that's the first restriction that we're working on getting rid of right now, is that bringing in the support for as of queries. And so this Apache Iceberg helps us to start to poke away at some of these restrictions that we have and bring more richer capabilities to tables that are no longer stored inside kind of native DB2 table formats, but in the more open data table formats. So that's number one. We now have that thing called a data lake table, okay? And that's basically a hybrid of external tables and DB2 Big SQL now available in the 11.5.9 code base. The second thing is remote tablespace support. And this is really about native cloud object store support. And when I say native cloud object store, I mean it's native DB2 tables stored in object store. Okay, so we support Amazon S3, and we support IBM. And this is a native DB2 table. And what that means is that you have full IUD support. Everything you do with a DB2 table and block storage, you can now do with DB2 in Cloud Object Store. And you might say, okay, well, why would I want to do normal, why would I want to store my DB2 data in Cloud Object Store? And the answer is, of course, price, all right? And so just taking a look at block storage versus object storage from a price perspective, you can see that there's tremendous savings that can be realized by storing data in Cloud Object Store. So now you can do that with native DB2 tables. Now, obviously, there's a trade-off, right? And that trade-off is in the form of performance. So for SLA type, very important turnaround time on queries, you're still going to want to use block storage because you are going to take a performance hit on, and you don't want to do that on performance sensitive applications. But you probably have lots of applications that are running that aren't as performance sensitive, and now there's an opportunity to save money, and it plugs into that whole Watsonx.data Lakehouse architecture as well, because you can store data on Cloud Object Store, which is where a lot of the other data is being stored, like some of the open data type capabilities, storage as a storage option for other data lake tables. Now, we do have engineers looking at how to minimize the gap in performance between Cloud Object Store and block storage. We'll never close the gap, but we are trying to make the gap as small as possible, which then means there's more and more classes of DB2 tables and applications that now become eligible for the cost savings of Cloud Object Store. All right, so now that we've kind of got that preamble in place, let's jump into DB2 Warehouse on Cloud SaaS. All right, Gen 3. And what did we do that? So the first thing is, as I mentioned already, this is a fully managed DB2 Warehouse on Cloud. It's called Gen 3 because it was actually a pretty significant change from Gen 2, and we're going to go through the key changes. And this is the first place that DB2 11.5.9 went out into the market, right? It was a cloud-first delivery, available on both IBM Cloud and AWS. And with that 11.5.9, everything I've talked about with the data lakehouse tables and the remote table spaces are now available to all clients and all deployment forms in 11.5.9, the full software release that went out in fourth quarter, as I mentioned earlier. But actually in third quarter, this all went out in the cloud. So that's the first thing. And then what we did is we introduced Cloud Object Store. So everything I just said about Cloud Object Store is available and has been available for pretty much a year now in DB2 Warehouse Gen 3, right? So you can use DB2 Warehouse Gen 3 fully managed and decide whether you want to, at the table space level, store data in block storage, or you want to store data in Cloud Object Store. Now, there is an important thing here that this brings to the table in the world of DB2 Warehouse on Cloud, and that's multi-temperature support. DB2 on-premise has had multi-temperature support. We've had multiple storage groups, and generally we, kind of paint a picture of a hot, warm, cold storage tier where you have like flash storage for your hot tier, and you can have like things like less expensive storage tiers like SATA drives, cold storage. And this was that came out in DB2Night something, I believe. It's been out there for years, right? Multi-temperature storage. And basically that whole concept is that you have hot, warm, and cold storage tiers, and you have policies that say, okay, data that's less than 2 years old is in my hot tier, data that's 2 to 5 years old is in my warm tier, and data that's older than 5 years is in my cold storage tier, because I hardly ever touch it. I'm just keeping it around, for 7 years for some, to meet regulatory requirements or whatever. All right. So now that we support multiple storage tiers on DB2 Warehouse on Cloud, you now have this concept of multi-temperature storage for your warehouse in the cloud. And that's very important, because in a very large warehouse, you don't want to have all of your data in an expensive hot storage tier. You do want to leverage less expensive storage tiers for data that doesn't need to be hot. It's not touched as much. It's historical data. It's sitting there. It's not changing. You're querying it once in a while. Doesn't matter if the query takes a little bit longer when you're going back and looking at something from 5 years ago. You want to only spend that extra money on a hot storage tier like flash storage or whatever. You only want to spend that extra money on the data that you're touching a lot and you have the performance sensitivity around it. So when it comes to DB2 Warehouse SaaS Gen 3, you now have kind of multi-temperature support availability, and that's brand new. The data lake table support, now there. So the ability to leverage Iceberg, the ability to take that expansion of our external table support to support Parquet and Avro and all those DB2 big SQL types that I've already talked about, that is in DB2 Warehouse Gen 3. You can absolutely do a create data lake table and get that support. All right, so what else did we do in Gen 3? All right, the first thing is we switched from what was called the common container to the universal container. What was the common container? The common container was used in our warehouse offerings actually started back in 11.1, sort of the end of the 11.1 cycle, and was there when we came out with the 11.5 back in 2019. It was an open Docker approach. It was also a single container approach, which means we just dumped everything into one container. So Spark was in there, a whole bunch of stuff was in there. And now what we've done is we went off and bought Red Hat. We also shifted our strategy from a DB2 perspective to the universal container. And that's whenever you see DB2U, we're referring to that universal container. And it is an open Kubernetes approach. And the first thing we did in 11.5, 1, 2, and 3 is made sure we supported Red Hat OpenShift. Obviously, we went off and spent a whole pile of money as a company on Red Hat, so there would be a lot of requirements to make sure we're fully integrating with the Red Hat capabilities. So we supported Red Hat OpenShift, and now we support DB2U outside of Red Hat OpenShift environments in both the cloud and on-premise, and more of an open Kubernetes type environment. The second thing is the second big difference between the common container and the universal container is the single versus multi-container architecture. So whenever you have to make an update to a component inside the container, you have to bring the container down, which means there's an outage. And in the world of needing more highly available applications, having everything in a single container, all you wanted to do was update your Spark library, and now all of a sudden you have to take a DB2 engine outage. And it's like, well, that's not very popular with clients. And so we have a multi-container strategy now where things like QRep and Spark and other components are in separate containers, and only the DB2 engine is in the DB2U container, which means the only time that engine comes down is because you're actually making an engine update. And that's what clients want. Now, we obviously have to then integrate with other containers, and we absolutely do. You can get your whole QRep, HADR support, and QRep has its own container that sits alongside DB2U, for instance. And QRep is, of course, our best practice when it comes to replication and DR in the world of DB2 DPF. And so all of that support is there, but it is in a multi-container strategy now. We also added in multi-database support for DB2U as well, which was a bit of an inhibitor for some folks adopting DB2U, and that has now been addressed. Highly scalable. So we have now taken the largest sort of t-shirt size of DB2 Warehouse SaaS in Gen 3 and moved from what was about 250 terabytes to just shy of a petabyte. So we're up in kind of the 800, 900 terabyte range now. And that's really important from the point of view of where are we seeing our clients move. We actually have clients that have EDWs in the petabyte range. We're not there yet with DB2 Warehouse Gen 3, but you can imagine there'll be like a Gen 4. We're not done yet. But we are up now to, you can get about a petabyte size warehouse into DB2 Warehouse Gen 3. And so it just opened for the, actually going back to the survey, right? There's a lot of interest in cloud. A lot of people haven't totally deployed in cloud. And one of the other inhibitors that have come up on deployment of cloud is like the cloud just not an effective way of dealing with very large warehouses. And now we're kind of chipping away at that restriction, and you know, pretty much up to a petabyte now we can support in DB2 Warehouse SaaS Gen 3. Now, in the world of very large warehouses, you can't be doing full backups every time you take a backup. One of the things that also prevented database customers, and this isn't just unique to DB2, from moving to the cloud is there was a lot of functionality that DB2 has inside our engine on premise that just were never exposed in the fully managed cloud environment. And so in a large warehouse, if you're going to have a 750 terabyte database size, you can't be doing full backups of that database all the time, right? You only want to be able to maybe take a backup of a particular table space or a particular schema or a delta backup, incremental backups. And DB2 provides all that capabilities, but it needed to be exposed in a cloud environment. And this is very important in the world of very large warehouses. And so we now have a much more granular, I'm talking about this one, more granular backup and recovery capability with DB2 Warehouse. So our schema level backup capabilities there. And by the way, schema level backup gives you the ability to have table level recovery, which is something that clients have been asking for a long time. Sorry, I had the wrong page up there. So then back to HA now. There is a variety of components involved in the HA world with DB2 Warehouse. Obviously, DPS, the data partitioning feature, MPP already has failovers built into it from an HA perspective. So if something happens to one partition, another partition can pick up, kind of pick up the workload. So there's HA built into DPF itself. We have our basically HA components that do the automated failover built in to DB2 Warehouse Gen 3. I mentioned there's availability capabilities built into the universal container as well. And of course, we've got QREP for DR. And so inside the engine, there's multiple components that all work together, whether it's Wolverine or whether it's Kubernetes or whether it's DB2 DPF itself, that all kind of come together and provide a very high degree of resilience for addressing HA. And then, of course, we have QREP to address DR requirements. Okay. So that is basically the highlights of DB2 Warehouse Gen 3. And just to summarize, it's got the new capabilities of 11.5.9 in there with the data lake table and the remote table spaces or native cloud object store support. It's now leveraging our universal container or multi-container, so that container does not need to come down anymore unless you are making a change to the engine. We've got the integrated HA there with Wolverine and Kubernetes, and of course, DPF architecture itself. We've got the granular recoverability capabilities, and we've got the ability now to scale up to just shy of a 1 petabyte warehouse. So DB2 Warehouse Gen 3 is a huge step forward in addressing both what our clients require from a warehouse, but also really making cloud a much more viable option for larger warehouses and breaking down some of the inhibitors that were preventing clients from moving to the cloud. Now, having talked about all that, let's take a slightly different turn here and say, hey, if you happen to be running our appliance on premise today, right? You've got a few options going forward, because over the next couple of years, IIS Gen 2 will be going out of support. It's not till 2026, still lots of time, but it's a good time to start planning for what's next. And the first place of what's next is, this may be a good time to say, hey, I want to use this opportunity to shift to a fully managed DB2 warehouse on cloud capability. And like you say, everything we just talked about with DB2 Warehouse Gen 3 helps as making it a very viable path forward if you're running our current generation of our appliance today. All right, so we've talked about that. We don't need to go through all of that again. The second thing is, as I mentioned, from a fully managed perspective, we support cloud and AWS today. Azure is next on the list, but I also saw some folks here that on the call today where Google is your strategic cloud provider, or one of your strategic cloud providers. Most companies are in a multi-cloud world anyways. And we support self-managed. So you can take the reference architecture that we're about to talk about, and you can deploy that on Azure. You can deploy that on Google. And then when we have our fully managed service that leverages exactly the same best practices as our Cloud Rack and on-premise solution does, which we're going to drill down on in a couple of minutes, we use exactly the same best practices in the DB2 Warehouse SaaS offering, and that'll become available in other cloud providers as we get that out. And Azure is next, just from a market share perspective, and then GCP after that. So that's option number 2. And we have already published a lot of the reference architectures out there so that you can deploy that DB2U-based warehouse architecture we've been talking about as a self-managed solution. And you can do that using AKS or Arrow, depending on whether you want to have Red Hat OpenShift or a non-Red Hat OpenShift environment, Open Kubernetes environment. And that information's out there today, and those are hot links in the presentation. And then now, if you decide, you know what, this is all very interesting about the cloud, but I think our next gen is still going to remain on-premise, how do I go about doing that? Well, the way we accomplish that is through the Cloud Rack. So what is the Cloud Rack? The Cloud Rack really is our next gen appliance, but I need to use the term reference architecture, and here's why. We wanted to give clients a hardware option, and I kind of hinted at this earlier. Power 10, power-based, is out there today. x86 is coming, and so it's not a pure appliance at purchase time, because you are actually making a choice on the hardware platform. Once you've decided that, hey, I want to do this on Power, or I want to do this on x86, then the experience after that, because the hardware and the software are acquired separately, the experience after that is all appliance-like. And so I do need to make that distinction. Unlike IIS, so if we go back in history, right, the Pure Data System for Operational Analytics and IIS, aka Selfish, they're both Power-based. They were both Power 8-based. PDOA ran AIX on Power 8. IIS shifted to Linux Power PC, but both of them were Power 8 hardware platforms. Now what we have is a Power 10 Linux Power PC option, which is this Cloud Rack. So it's basically taking, if you want a solution that's closest to IIS, that's the Power 10. Because what's happened is we've upgraded, and I'll show you the path forward. If you actually want to take this as more of a step towards commodity hardware, which is a natural step towards getting to the cloud eventually, and you want to switch over to x86, then that's a hardware platform change from what PDOA and IIS are today. Now, why do we do Cloud Racks, right? Organizing a very large warehouse requires following a set of best practices in order to get the performance that you want and the price performance that you want, right? You're spending a lot of money on a warehouse, and you want to get the most value out of that money. So there's a bunch of best practices that need to be followed around the balance between compute capacity and storage as it pertains to your hot data, and how to configure DB2 to optimize in that space. And so really a Cloud Rack when we call it a reference architecture, it really is that. That same reference architecture gets used in our DB2 Warehouse on Cloud SaaS offering. That same reference architecture is out there if you want to do a self-managed, and that same reference architecture is built for you if you decide you want to do an on-premise deployment with a Cloud Rack solution. So it gives you the flexibility, the efficiency, the simplicity, which is you don't have to go figure all this stuff out for yourself. We've figured it out for you. We just need to know some details about your workloads and concurrency from the number of users and how, what's the size of the warehouse and how much hot and cold data do you have. And then out comes a prescription, right? It's a reference architecture. It's prescriptive, right? We can give you something that's totally optimized. So the first one that went out there is the Power 10 based, as I mentioned already. It is the most natural evolution to IaaS, which is the appliance that most clients are using today if they're running the appliance form factor. And I'll show you how we kind of bridge from one to the other. The one thing I want to really mention here is sort of the white glove service stuff, right? The IBM services. So part of how we make this an appliance experience, an appliance-like experience, is that once you've said, yep, I'm going to run the Power-based or the x86-based Cloud Rack, we bring in the people to build it out for you, get it up and running, and basically it's create table ready, okay? And then we can provide support. Some of it's built in, like doing maintenance, like installing software patches for the operating systems, for DB2 and so on. That kind of thing is all built in. And then you have optional extra services that you can get as well if you want to do some performance tuning or a health check or capacity planning. So there's a whole rich set of services that can be provided. Some of it's included in the Cloud Rack purchase price itself, and some of it are extra things. Like, for instance, all the things I just mentioned, I think, are included. So like the capacity planning, health checks, all that sort of stuff. But if, say, you actually want us to come in and do the migration for you from IaaS to PDOA, then that would be something that would be kind of an extra charge that you could just wipe your hands of the whole thing and say, great, I'm buying the Cloud Rack, go move my IaaS environment to Cloud Rack, or even my on-premise environment that's just leveraging VMs or whatever you want to move into the Cloud Rack reference architecture. That the migration work could be acquired there as well. So just taking a look at what's changed, right, between Sailfish and this. The first is, as I mentioned already, Power 8 to Power 10. So you're getting a tremendous gain in jumping 2 generations in the actual underlying servers, right, the Power 8 to Power 10 servers. We've also upgraded the storage from the 900 flash modules to the 7300 flash modules. We've improved the network from 10 gig to 100 gig. And also, of course, you're getting the modernized DB2 warehouse on OpenShift. So you're moving from that common container to the universal container, and you're going from you're now starting at DB2 11.5.9, which is available today. So you're getting all of the capabilities that you require to plug into that Watsonx.data Lakehouse architecture as well. And here's what a partition looks like, or an MLN looks like, right? The multiple logical nodes. Each server has 8 MLNs, or 8 partitions of DB2 DPF. That's consistent between Sailfish and the Cloud Rack. We now have 4 Power 10 cores versus 3 Power 8 cores per MLN. So that's a huge compute capacity gain, right? Just the Power 8 to Power 10 is a big jump, and now you've got 33% more cores per MLN. We've also jumped from 1.5 terabytes to 3 terabytes of space per MLN, so twice the data size. And we have jumped in memory, basically doubled the amount of memory per MLN. So each MLN in the Cloud Rack is very powerful, right? So as I mentioned, you've got a 2-generation jump in your processors, you've got additional processors, you've got twice as much memory and twice as much storage space. So very, very powerful MLNs, lots of room for capacity and growth in the Cloud Rack. And here's basically what it looks like. So there's sort of three pieces to this appliance. Look, the first is your control nodes on the left, and they're there to run Red Hat OpenShift. Now, if you have a Cloud Pak for Data system today, you do not need this for the Cloud Rack. You already have a highly available component for Red Hat OpenShift. And so you only need that once, and you can run Cloud Pak for Data System and the Cloud Rack off of those same three racks. But this is DB2U, and it is running with Red Hat OpenShift. And so if you don't have Cloud Pak for Data System, then you would need those control nodes from a Red Hat OpenShift perspective. And then you have your DB2 worker nodes, okay? And you can have as many of these MLNs, as many of these servers, and as many of these racks as you need. Grow as big as you like. We've got clients up in the 2.5 to 3 petabyte range running with this type of topology. And so the DB2 worker nodes just grow as you need it to grow. You get about 11 to 12 data nodes per rack, and all the availability is built in within a single rack. And we already defined what a single data node was, right? The 8 MLNs with the amount of memory and storage and compute capacity and storage capacity was all just defined on the last page. So you get 11 to 12 of those inside one rack before you have to overflow into a second rack. And then you have the ability to grow your storage and compute capacity separately, right? So you get an amount of storage and all this stuff for hot data inside the MLNs, but you can also have an optional storage expansion, which is perfect for that multi-temperature support, hot and cold storage tiers. You put your hot data in the 3 terabytes per MLN storage that's provided. It's all flash in the data server or data nodes, and then you can have an optional expansion of a storage tier in addition to that if you've got a lot more data that you want to have on a colder storage tier. So you basically have that multi-temperature support that we talked about earlier for the whole Cloud Rack. And of course, yeah.
Can I ask a question, Les? So when we
Absolutely.
expand, for example, when you add a new MLN, how is the data distribution going to carry out in the background? Is it going to be automatic, or do we have to perform additional task of redistribution using the table redistribution commands and such like that?
Yeah, so no, a great question. So in the end, a DB2 redistribute needs to take place, right? So if you come in and add, say, 5 more data nodes, you now have, let's say add 5 more data, you now have 40 more partitions, and the data needs to be redistributed. And it's done through DB2 redistribute. That is included in say, the migration update as part of the built-in services that I talked about. So someone's taking care of that for you. But one of the things that clients do get concerned about with redistribution is the fact that they may perceive that they have to take an outage. And what's really cool now with the support of external tables and native cloud object storage, you can actually go and decide, okay, I'm in the process of redistributing some tables in a particular table space as part of that redistribution. And so I'm going to go create external tables, or I'm just going to actually create a remote table space for that table space in Cloud Object Store, for instance. And now you have, you can continue to be online. If you just use external tables, then it's a read-only online, right? You can't do the update deletes, but you now have all your queries still working against those tables. Or if you decide you want to have a remote table space, you'll take a performance hit, but that's a native DB2 table out there. So you could do like basically a copy of the table space, and then you can, and basically have, you can, with some extra steps, you can have an online, either read only or read write online redistribution with some of those other capabilities I've been talking about already.
Great. Thanks, Leslie.
Hey, no problem. So I've already talked about the services, right? All the installation, migration, capacity planning, all that stuff, all built into this sort of gold glove care. And if you want to actually have us do the whole migration for you from wherever your starting point is to the cloud rack, then absolutely there's optional optional services that can be provided there as well. And basically, one of the best practices we learned from Netezza that we did not have in our old PDOA world, and we didn't, we should have done this in IIS but did not, is the concept of a TAM, a technical account manager. So that person who's giving you the services is assigned to your account. They know your environment, they know the topology, they know how many data nodes you have, they know the kind of data you have in your workload and all that sort of stuff. And they are an account manager, a TAM that is assigned to you, to your account, and is there for you through the journey. And that's exactly the model that Netezza really, the Netezza customers really like the whole TAM concept with when we acquired them and we saw how they had that set up. We should have done this with IIS, we did not, but we have learned and now have that TAM concept there assigned to your account as part of the cloud rack offering. So as I mentioned, we're supporting IIS Gen 2 out to 2026, which is where all the existing appliance clients are. Lots of time, right? So still a little over 2 years. But now's the time to start thinking about, okay, what are you going to do if you're an IIS client today? You're going to use this as an opportunity to go to the cloud. We've talked about that. Or you want to still stay on-premise. And we've now shown what the solution is for on-premise. And by the way, moving, of course, to DB2 Warehouse Gen 3 or to the Cloud Rack, as I mentioned before, it can be from any sort of custom, on-premise, bare metal, VM environment as well, right? It doesn't have to just be from from a past appliance. It could be from any footprint that exists today. So that kind of wraps up the warehouse. But I just want to give us I mentioned vNext, right? And of course, there's always questions about what's coming next, especially when I drop the little bomb there that says, and by the way, there's going to be no new function on 11.5 now. So what have we got going on later this year? The first thing is we're hoping to have a DB2 version 12 out in fourth quarter of this year. We're going to continue to invest in our Amazon RDS, of course. That was the sort of the big transactional OLTP announcement, nothing to do with warehousing. That's an OLTP announcement. It is a single node topology. I mean, you can run warehouse workloads on it in a single node, but there's no DPF component to that RDS. It's a single node SMP DB2, but there's no reason you can't create organized by column tables and have some analytic workloads running there, just like in any non-MPP topology of DB2. We're going to continue to invest in our DB2 Warehouse Gen 3 environment, and we're going to expand that out from AWS to Azure. We're going to close some performance gaps with the Cloud Object Store, continue to chip away at some of the restrictions on the data lake tables, such as of queries and update deletes and things like that. We're going to continue to infuse AI into DB2. I'm sure most DB2 clients have heard about the AI optimizer. And so in version 12, that AI optimizer is going to GA. And it'll be ready for production use. It is not turned on by default. It'll be something you have to turn on yourself. We always want to tread carefully when it comes to optimizer changes. So that's why it's turned off by default, but you can test in a test environment and then say, yeah, this is working real well for me and my workloads, and then we'll turn it on. We're doing some work around our user experience with our management consoles. We have this is obviously not warehouse specific, but pure scale improvements, replacing, and this does affect the world of warehousing. TSA on Linux is being replaced by Pacemaker. TSA was used in all of our failover topologies on AIX and Linux. So that would be pure scale HADR and DPF. So obviously in a DPF environment, which is the whole world of warehousing, will be Pacemaker in version 12 on Linux. Multi-tenancy. Basically a tenant is a database object below the physical database and above a schema. So one tenant can have multiple schemas. And you can have, each tenant can have the same name schemas and tables and store procedures and all that sort of stuff. So it really is a true multi-tenancy type of topology and construct there. We talked about the AI-powered optimizer, GAing, and infusing Gen AI into DB2. Whenever we talk about AI, where do we have models inside DB2, right? We have obviously the optimizer, which I mentioned already. Our memory management, right? Remember way back, it was like in version 8 or whatever, when we were doing all our autonomics. We had the self-tuning memory manager that would do all the sort of backroom trading of memory for sort heap, and memory for the logs, and whatever's being used here. If we have surplus memory here, we can lend it out over there and whatever. And that's a model, right? And so we were applying AI to that. The other place is workload management, right? And the automated resource management that we put into place for warehousing. We call it AWLM, automated workload management, but it's really automated resource management based on historical trends. And we can apply AI to all of those areas in DB2 to make DB2 a smarter engine. And then there's a whole long list of other capabilities and enhancements we have coming with version 12 as well, with ITP and enhancements to PureScale, online index reorg for PureScale, admin move table enhancements, security enhancements, federation or data virtualization enhancements, lots of different areas that we've got coming for version 12. So stay tuned for more and more information. And this kind of, I think, will take me to my last chart here, which is obviously being part, I'm sure probably most of our users know about iDoug. DB2 is going to be launched as part of that Valencia iDoug Europe event at the end of October, right? I mentioned version 12 is coming out in the fourth quarter, and one of our launching points for that is going to be iDoug Europe. That's set up for Spain at the end of October. And so keep that in mind. It's a great place to come and hear about the latest and greatest with DB2 version 12. If you're in the Americas, right, you might be saying, okay, well, I'd love to go to Spain, but I'll never get approval. Tech Exchange is the week before iDoug Europe, and it's in Las Vegas, so it's very Americas. And it's the week of basically the 20th to the 26th. And so that'll also be a big place to get more information about DB2 version 12 as well. And so that's pretty much what I've got for today. So I'm going to turn it back over to Mohan and Martin for any closing remarks, questions in the chat room, closing surveys, whatever it is you've got lined up for us.
Awesome. Thanks, Les. That was a great insight to data warehouse, DB2 features, and the launch dates. Thank you. I'm going to take the screen back again. All right. Today's show sponsor was DBI. DBI software is, and the dashboard would look something like this if you install the product. Now it is a lightweight process which built in, where you can have the process running on a different server, and then you can use the thin API calls to read the data and then make the judgment or the decisions based on what you see in the dashboard. Right, so that's going to be we're going to launch one last polling question before ending the session. That's going to be our regular, did we learn anything today? All right, so let's wait for about 5 more seconds and then we'll close the poll. Right, closing the poll. Yep, we got 100% from the audience. Great. Thanks, Les. Thanks, Martin. Thanks, everybody, for joining. And we'll see you again in the next session.
Thanks, Mohan. Thanks, Les. Great to hear you both.
Thank you. Take care. Bye-bye.
Bye-bye.